Here's a video for 7-1, which is graphing systems of equations. So let's first define what a system of equations is. A system of equations is a set of one or more equations involving multiple variables. So in this particular class, we're going to look at systems of linear equations. So when we have one or more linear equations, and then we're going to learn how to find the solutions for those systems. So a solution to a system of equations is a set of values for the variables that satisfy all the equations simultaneously, meaning at the same time. When we're graphing systems of equations, which is what we're going to do now, the solution is the point or points of intersection. So where the two lines cross would be the solution to the system, because that is the only point that makes all of the equations true simultaneously. So we're going to look at examples in the next slide. All right, so it says to graph the following systems of equations and identify the solution. So we have f of x equals 3x minus 1 and f of x equals negative 2x plus 4. So first of all, remember that when we have f of x, that's the same thing as saying y equals. So if you prefer, you can rewrite it like this. So what we're going to do to graph these system of equations is we're going to graph each line separately, and we're going to see where they cross. So starting with the first equation, so since our y-intercept is negative 1, we're going to start at negative 1, and my slope is 3 over 1, which means I'm going to go up 3 to the right 1. So we're going to go all the way off the graph in both directions. This is especially important when graphing systems. It's also important to make sure we use a ruler when we're graphing systems. So then from here, we're going to go ahead and draw our line as best as we can. Okay, so there's our first equation, that is y equals 3x minus 1. Now we're going to graph our other line. So we're going to start at positive 4. My slope is negative 2 or negative 2 over 1. So I'm going to go down 2 over 1, down 2 over 1. So I already see my point of intersection, but I'm still going to graph all the way in both directions. Okay, so now we have our other equation, y equals negative 2x plus 4. And now for our solution, we're going to look for the point of intersection. So as I can see, my graphs cross here, and that the coordinates of that point is going to be 1, 2. Let me do that in a little bit of a darker color. So 1, 2. So that means my solution is going to be 1, 2. Okay, what we also want to do, would be a good idea, remember that the solution is the set of set of values for the points that make both equations true. So to check, we're going to plug it into both equations. Remember to plug the first number in for x, the second number in for y. So it's starting with my first equation, it's going to be 2 equals 3 times 1 minus 1. So that's 3 minus 1, so 2 equals 2, so that's good. And now I'm going to check the second equation. So it's going to be 2 equals negative 2 times 1 plus 4. So that's going to be negative 2 plus 4. 2 equals 2, and that's true. So since it made both equations true, that's how we know that this is the correct answer. All right, we're going to do one more problem. Just to make sure that we understand how we're doing it. So first thing we're going to do is we're going to graph each equation separately. So starting with the equation on top, we're starting at 1, and my slope of negative 2 tells me to go down and to the right. So here's my first line. Now I'm going to graph the second line in blue, so we start at negative 4. My slope is 3, so I go up 3 over 1. And then I see my point of intersection here, so my solution is going to be 1, negative 1. Okay, it also says to check our solution, so what I'm going to do is I'm going to plug them into both. So remember, I'm going to plug this in for x and this in for y. So it's going to be negative 1 equals negative 2 times 1 plus 1. Negative 2 plus 1 is going to be negative 1, and negative 1 equals negative 1. So it's good for the first equation. Now we're going to check for the second equation. So we have negative 1 equals 3 times 1 minus 4. So I have negative 1 equals 3 minus 4, and 3 minus 4 is negative 1. So it works in the second equation. So that's how we know that this is the correct solution.